Our first slide is really to look at circles and the fact that they're found in nature, from the simple raindrop falling on the river or the pond or the puddle, to there's plenty of that around at the moment, to spectacular sites like a double rainbow at one of my favourite sites in the Pembrokeshire National Park, Lecadribeth, big slab on a tripod in Welsh, very colourful language, and there's the double rainbow, and that's an arc of a circle. There are built circles, of course, in our environment, and there are sky circles and living circles. We see the disk of the sun and the moon, and we see the sunflower, which obviously is part of that. We saw the picture of Mary surrounded by that in Bert's talk, and there's the transit of Venus just happening there across the surface of the sun, because I still do that sort of mad thing. It's only once in my lifetime, twice in my lifetime, that I'm ever going to see that. And I got the first one in 2004. There's the disk of the sun, and there's the planet Venus. You see how small it is, and how small we must be, how little we are in the immensity of space. And there's a nice built circle, or an arc of a circle. There we are. And there's some lovely circles there, about which there's been a lot of controversy. That's sort of the power point of London, isn't it? Battersea Power Station. And then we've got prehistoric built circles with savages. And there they all are. And mysteriously, these stones have materialized overnight. And Busty Taylor's on an eagle overhead. And they're trying to think that they couldn't do it. So it's impossible, but there's a nice henge with a double ditch and so on. So it all leads us to the fact that human cognizance of the relationship between the perimeter or circumference of a circle and its radius or diameter, and whether you use the modern way of using the diameter as the constant or pi, the traditional one, it's really not that big a deal because you can do either. And I can be flexible enough. So, but the two formula that we learn at school are 2 times pi times the radius gives us the circumference, or twice the diameter times pi is the circumference, and pi times the radius squared equals the area. Now, there are several constants found throughout history used to simulate convenient values of pi r 22/7, which you used at school. In the days before electronic calculators, these were very important for, should we say, less than 100% precise. They're not bad. You can't do many things in life to 99.96%. I certainly can't even get Rice Krispies into my mouth with that precision. And the most accurate, I don't know, I don't eat Rice Krispies. I don't know why I said that. It's absolutely awful food, but it is awful. It is difficult to get in your mouth. All right, that's why I said it. It's not like our local whole food muesli, which is difficult to get out of the packet. The most accurate one we know is this one, 355 divided by 113, and that's almost spot on. I mean, there are so many noughts there as to make it indistinguishable in any practical engineering project, I would have thought. And the historically used value is this lovely 864/275, which is the one that you find in the Egyptian monuments. Again, and quite a few times there's a rough approximation there. So there's pi. I don't want to do this a maths lesson. This is the end of the talk. I can't do Bert, but you're not following me fast enough. You manage with Bert, you can do it for me. You were asleep. You want to see a crop circle being laid? Right. Guess what? It's Bert. So, and it was a great lecture. I'm not mocking. That was a fantastic choreography. So, sooner or later, people appear to have got the message that there was this relationship, and the sky was also informing people of geometry, whether they liked it or not. As soon as they started monitoring where Venus stopped in the sky, which it does every 1.6 years, they would notice an 8-year sequence and 5 stops. And there it is from the year 1990 to 1990 something or other, 98. And it stops at these 4 points, and each time you can draw the pentagon, the little arrows there show where it stops the next time. So it actually can be drawn in one single stroke of the pen. So there's the Earth. We've drawn it in the middle because it appears like the Earth's in the middle. I don't have a problem with that either, but modern astronomers really do have a problem with putting the Earth at the middle because they think naively that we don't realize where the Earth is. But, you know, if you're on a railway train measuring the velocity of another vehicle next to you, you don't pretend the railway train's not in the middle of things. It's where you take your measurement from. You'd get very badly injured if you did. So there's the Venus pentagon, and it's, of course, loaded with other constants like phi, which we don't need to cover. But what I want to say to you, first of all, a central theme of this lecture is that time and space are involved in this process. It's no longer about just space. You have to wait the 8 years, and you have to remember which star Venus stopped next to in order to record over 8 years. It requires a certain level of consciousness and measurement and observational accuracy in order to define this. It is a pretty accurate pentagram. It only moves 2 degrees at the end of the cycle, so it takes sort of 1,000 years to rotate slowly around the sky. But there it is, the Venus pentagram. Those of you who were up during the fine weather in the spring, when the weather was looking like it was going to be nice in the summer, will remember that Venus, for night after night after night, was gradually slowing down in March and April, a wonderful spectacle. Every month the moon was going past it, and you were getting a free Muslim flag in the sky and things like that. It was a very good time. That was one of these points. And so the discovery of astronomical geometry and meteorological geometry and a geometrical framework coming from the cosmos, we can imagine must have appeared wonderful. It must have appeared like there was some mystical or numinous force, called God in my language, we don't need to give it another name really, that was responsible for order in the cosmos rather than the chaos that everybody is so scared about, even today. We don't like chaos, do we? Anarchy, chaos, we don't do it. It only lasts, it brings change, but it's basically a very uncomfortable thing. We like security, we like to see these patterns. They tell us that things are going to continue. And there's another one from Babylon. This is a really cool bit of stuff that survived all those years and is in our culture today. There's the moon there. It's the fastest moving object in the sky. From night to night it moves. I keep saying guess what like Burton, I must stop doing that. Guess what? It moves 13 degrees, as you might expect the lady to move. And therefore it's a very fast moving. Mercury can make up to 2.5 degrees in a day, but it follows the sun. It's always near the sun. So its average is at 1, but when it's really going for it, Mercury, it fair shifts per night for night against the stars. Venus is a bit slower, but that's our third fastest. The sun moves 1 degree a day, which is where the word degree comes from. Mars is quite slow. It takes 4 days to move a degree. And Jupiter takes 12 years to go around the cosmos, so it's even slower. And finally, we've got Saturn, which takes 29.4 years to go around the cosmos. So there's the planets represented in order on a heptagon of their speed. Now, so what, you might say? What's that got to do with it? Well, first of all, why would you choose a heptagon? Well, the answer is that throughout history, we've always had a 7-day week. And 7 is a very big number in many religions, the Jewish religion particularly. And we've chosen, even in our modern calendar, to try and stuff a 7-day week into a year that doesn't divide by 7. There are bigger problems, like we have a square calendar for a circular process, which is also bonkers. And we could change this. When we look in the mirror and say we are divine beings and we could change everything, but we don't, which has been said by 2 speakers, we could actually rip up the square calendar and start to think about designing a good circular one. There are such things available, I know. So what's this got to do with the days of the week? Well, the answer is that if you start with Monday, and you make a heptagram, you go from Monday and you go to Mars, which is Tuesday, and then you go to Mercury, which is Wednesday, Mercredi, and then you go to Thor, which is Thursday, or Jupiter's day, and then you go to Dydd Gwen in Welsh, which is Friday, which is Freya, and then Saturday is Saturn, which is Saturn day, and then you've got Sunday, and back to Monday. And you create then a heptagon star in the order of the days of the week. Now, this is mainstream. I mean, any historian will avoid it, maybe, in a university education, but this is well known. It's called the Chaldean order. But the point is the creation myth in our Bible, and the Western Bible, which is poached from the Babylonians, is about the order of creation. And it's very difficult to know where to start with that, because some people start with the sun, some people start with the moon. But if we say, let there be light, there's the sun, and then the division of the waters, that's the moon, and then we've got the dry land, which is Mars and deserts. And this connection runs right through our mythology. Mercury, which is the signs and seasons and measuring and portents. Justice, sea beasts and birds, is Jupiter, which reminds us that before Neptune was discovered, that the leading ruler of Pisces, the sign Pisces, was Jupiter. And then we go over to Venus, which is reproduction. That's the fun bit, if you're a mammal. And then Saturn, the day of repose, and Saturn's to do with structure and the end of a cycle, and back then to the sun again. So this is where our days of the week come from in almost every language, every Indo-European language. How many people haven't seen that before? No, it was worth putting in then. Yeah, okay. So when you read your Bible next time, you'll connect directly with something that was going on in Assyria. The myth of creation in the Assyrian was the Lima Elish. And so that leads me on to astrology, which is a very much, I mean, it's rubbish, isn't it? Because Brian Cox said on Sunday night. But, you know, again, we're into time and space. And the signs and the constellations made it necessary to refine measurement and produce star charts. And however crude some of those early ones may have been, and they weren't that bad, there's clay tablets that weren't bombed by the Americans that still survive that are pretty accurate. These two acts together, working with both space and time, resulted in an accurate calendar, plus an accurate framework for astronomical observation. It also led to predictions through astrology, and I'm not here to talk about astrology, but that's a chart of 9/11. Okay. I won't let you analyze it. And there's observation and measurement. And this is what one archaeologist had the courage to say. He said that measurement began through looking at the cycles of time rather than from direct putting a ruler on the ground. And measurement in human history began with observations of time and time recording. And it's at the fourth dimension. It's non-material. And measurements of time were at some stage transduced into spatial dimension, recorded as marked lengths of rope or regular notches in bone. Now, my brother and I have recently been doing work in Brittany for the last 4 years, and we've discovered sites in Brittany that have in inches multiple numbers of years and the major cycles of the sun and the moon built into them. And sites in Britain, particularly in the Lake District, have the same thing in feet. So if you go up to Long Meg in Cumbria, the big stones that go east-west at Long Meg, they're really big. They're 5 foot deep. You know, they're 5 foot out across the circumference of and they're more or less east-west, a couple of degrees out. That if you measure them with an accurate, you know, a fiberglass tape measure that you'll go and get from your builder's merchants, good enough, you'll find that the length in feet across the inside of those is 354 feet and 4 inches. And that's the length of 12 lunar months. And to the far side of the stones is 365 and a quarter. Now, what can that be? What could that be? Those are the most important things an astronomer needs to know. He needs to know how many moons there are in a year, and that tells you the difference is 10 point something days. And it's there, in feet, in the 2 biggest stones in the whole monument. I could go on, but I'm not going to. At least not about that. And there's repeat cycles of the sun and moon, which if you keep observing them, you're going to not miss. And it's amazing how many whole numbers of years, in such a short space of time, there are 3 good synchronicities between repeat cycles of the sun and moon, and there is a 4th not so good. The 3 one seems to be applying well, we don't need to look at the sites at the moment, we won't be specific, but after 3 years, there are 37 full moons to within 3 days. You'd think that was pretty close. 1,095 days, within 3 days of 1,095, that's pretty good. At 5 years, the Caligny calendar is one example of the 5 years. There are 62 lunations. That's 2 days. So it's not bad. After 8 years, 99 lunations, 1.5 days. And Avebury seems to reflect that in the number of stones in the outer circle, which is 99, the big circle, and then the fact that the inner circle, as the inner circles are the two cycles, the 2 monthly cycles of the moon, the star cycle, the sidereal cycle, and then the phases, 27 and 29. Now, when you look at these numbers, they're not very godlike, are they? We would expect God to work with whole numbers, I guess, you know, but that's not how it is. It's actually, you have to work hard to see through these very, very long fractions that in fact they come together in simple numbers as repeated cycles. The whole of our calendar today is running on this 19-year cycle where there are 235 moons. It determines when Easter is, it determines a lot of things. It's within 2 hours. We've no right to demand that it could be that accurate by chance. And Stonehenge, like a lot of stone circles in Britain, have 19 prominently marked as numbers of stones in their perimeters, and sometimes even within the stone. I've written Newton's three-body problem because my friend Isaac Newton, who sits on my shoulder occasionally and says naughty things to me, said, never did my head hurt so much as working with the cycles of the moon. He had to try and solve the motion of the moon. He never did my head hurt so much. And I think I caught a glimpse of that during the last 20 years. My head hurts. And there's a circle in Cornwall, Boscawen or Een, depending on whether you're Welsh or Cornish, which shows the marriage of the sun and the moon represented and would be a very good indicator or example of cultural recognition of this cycle. Now, I obviously am now driven by my evidence and my critical faculties to say that they were bright people. And Alexander Thom, a far wiser man than I'll ever be, a doctor of science and PhD and all sorts of other things, said, I have come to recognize that in terms of their ability to think, the megalithic circle builders were in many ways my superiors. He said that on mainstream telly, and it wasn't very popularly received by a lot of people, particularly archaeologists. It smacked of reverse evolution. In other words, we're a bit thick. And there's the editor, then editor of Antiquity. As archaeologists, we are constantly beset by the lunatic fringe. And then he also said, as editor of Antiquity a few years earlier, the problem with archaeology is when to stop laughing. Now, when people can't stop laughing, they are generally thought of as being fairly insane. So, yeah, well, poor old Glyn's no longer with us, but this was the battle going on between this man and the one on the previous slide. He turned against Thom in a really vicious way. And so there's midsummer sunset at a site within a few miles of where I live, 3 miles of where I live. And the sun, you've seen this before. Anyone who's been to one of my lectures before will have seen this. The sun shines through a little triangle on this side of the monument, and as it sets, it moves over to that side, where there's another little triangle. These 2 back stones and a front stone. It's like a Reliant three-wheeler underneath. In fact, it even looks a bit like a Reliant three-wheeler. And then this summer, for the first time in years, despite the weather, went up there with very little hope, and we picked up a sunset at Lekadribeth this year. And I moved, that's not a triangle anymore, I moved this way to show that the sun, the tip of the sun passes down through there. And what is interesting is that's the sea level. And there is a mountain in Ireland that it sets into, which was clearly visible this year. It's the biggest mountain in the Wicklow Hills, 93 miles away. Now, the whole axis of symmetry of the monument is based on that point. The horizon's here. Now, no Photoshop has been used on this photo. It's a real photo. I'm down on my knees, as I often am in front of these things, and the grass is not as tall as it looks. The monument's 11 foot tall there. And there's what the archaeo-astronomer, Royal, if you like, the chap who was the professor, wrote in a popular book for the likes of you and I to read, to stop us ever looking for ourselves because it's a waste of time. There is no evidence the use of astronomical observations for practical purposes, such as the determination of the time of year. The idea that distance horizon features, such as notches, could be used to pinpoint the motions of the sun and moon to a few minutes of arc have now been discounted. What it should say is by me. Because I call that an alignment. 93 miles long, it's a rifle barrel with a hell of an accurate track. And it picks up the solstice, or it did when the monument was built. What I've had to do is move a little bit to the one side. But the correction is known, it's a mathematical thing, and I can do that, and it's okay. So let's now look at the geometry of crop circles. Over half of crop circles are not circular. We said yesterday a lot of crop circles. Did I say crop circle? Or stone circle? Right. Well, over half of stone circles are not circular. Yesterday, a speaker said that a lot of crop circles are not circular. Now, that geometry there is formed like that by dividing a circle into three. You can do it by creating the ubiquitous vesica piscis, and then you take a master circle through 3/2, 1.5 times the radius, and you come up here, and then you walk a rope from that point round the peg here to there, and then you just walk it round and disengage the peg, do that nice flattened arc, hit the peg there, and down you go. It's as easy as that. And this shape has appeared in crop circles. You're all familiar with that. For years, the vesica has been used with additional circles. I even think it's the logo for an alternative venue for studying crop circles. There it is, the type B flattened circle, and I want you to draw your attention to the fact that, in fact, you put 3 circles in the middle, and that middle circle there is contained within the vesica. And the perimeter of the flattened circle, compared to the eclipsure, the circle, if you completed it, would be the year, and that's the eclipsure is the flattened perimeter. That's very strange, because the circle perimeter, that is 364.242, and the eclipsure is 346.62. So this flattened bit lessens the circle, and within 1% of those two figures is the lessening. So this is pretty good. And there's another type of flattened circle that does the same with the 12 lunar months. So if you're into calendars, the perimeter is doing something that is not just geometry anymore, but has astronomical use as a recording instrument. People say, well, how did they record all this? Well, there's a circle which does it. And there are lots of these. There's over 40 or 50 of them in Britain and a load in Brittany. There's another thing that's going on in this circle, that the largest cycle of the moon, the major standstill cycle that occurs every 18.618 years, occurred in 2006. Have you all heard of that? Do you ever notice that the moon rises well into the north every now and then in your life? Far more than it usually does? No. No, well, you need to get out more. You need to stop watching Brian Cox. That number, if you make it the radius of this point here, and let's remember that 18.618 squared equals the eclipsure. Now this is magic, because this is order in the cosmos. This number squared equals the eclipsure that represents compared to the circle that's in there. It's the same sort of thing that we get going on in crop circles, where there's a clever bit of jiggery-pokery going on, that if you decode it or get into it enough, if you're conscious enough, you're going to find some sort of connection with a higher form of order. The middle number there is very like pi, but the one to draw your attention to is this one that's done something silly, which is dropped an 8, but it's 12.368, which is the number of moons in a year. So already we've got the number of years it takes for, it's really mixing our lingo here, we've got the number of years in a moon's rising and setting cycles, major and minor standstill occurring at the two peaks, the upper peak and the lower one, and we've got the number of moons in a solar year across there. And it happens that if you do this Pythagorean bit on that, this one is exactly one more than that one. 18.618, 19.618. Now, it may completely pass you by that that is quite strange, because we've got something there that's a rate, it's got no units. There are 12.368 moons in a year. That's number of years. And the ratio of the circle to the flattened bit is the ratio of the eclipse year, which that squared equals. That's bizarre in itself. In days, the eclipse year is 340, well, we can see it, it's 346.62, and that is 18.618 squared. Are you interested? Should we go on? So there are three formulae that I just found, just quietly over my Rice Krispies one day, which are, there's the first one, that 18.618 times 18.618 is the eclipse year. I mean, we're talking decimals here. We're talking, this is not 299.3%. We're 99.99, all of them, or higher. 18.618 times the other triangle length, 19.618, makes the length of the solar year. And 18.618 times 20.618, which we've no example of in this thing, but it's 2 more, makes 13 lunar months. So if you make this shape, and you've got a length of rope, you can do all the manipulation you like to create a calendar, predict eclipses, and find out when moons are going to be full and new. And this crops up with not just this shape, but with plenty of others. Now, I've given you a taster. That's what I do. It's that sort of information that makes all the hours of tramping over wet moorland and setting up theodolites and shouting at my partner and being shouted at back, because that's what happens if you're half a mile away. We're not having a row. Really, we're not having a row, promise. So let's have a look at this 18.618 again. The longest term of the moon that is commonly measured is that one. But the sun has a long-term repeat cycle of rise and sets too, and it's 33 years. It's the basis of the Christian crucifixion story. It's also the basis of Freemasonry. It's a number you've all met before, and in fact, if you've been up near Silbury Hill on May in 1997, you'd have seen the 33, which has been shown as a slide, the toroid with the wavy arms that was regarded as the Beltane circle, or it had another name. Point is that these two numbers here square the circle so accurately it's almost would be impossible to you to detect the difference. 33 squared is 1,099, is it? Yeah, something like that. And 18.618 squared is 1,098.6 something, something, something. So this makes a more accurate squaring of the circle by area, not by perimeter, the areas of these two shapes. I know it's distorted a bit. Something's gone a bit odd with the distortion there. I want to get across to you that the squaring of the circle happens in time with these two cycles of the sun and the moon. They are giving us two cycles which, if someone's conscious enough to measure those numbers, and I can find you sites within 5 miles of my home that do both of those quite easily, and if you waited for the time length, you would know these numbers. You don't need to even, it comes in packets of 1. I mean, the end of a year it happens on the same date, or the sun's setting in the same mountain, or in the case where I live, in a notch in a mountain. And there is a site set up there. This is measurable at lots of sites. And what I want to impress upon you is that this is a very accurate squaring of the circle. But if you're not looking for squaring of the circle by area, you're missing half of the bit of squaring the circle. And there's only a few researchers, one of whom sat here, and a few others you've heard, who are doing this work. And therefore you could miss something quite important, because this is a communication. What else can it be? We've got a massive amount of order happening here. And so part 2 starts to look at the rise and measure the temple of God and the altar, the revelation of St. John, chapter 11, verse 1. And there's a nice Blake picture. Francine. Now, we're going to look at the work now of somebody who's been mentioned a lot, but I don't think many of you here may not, well, I don't know, I can't prejudge, but I guess most people are not really aware of the contribution made to this sort of research that this guy made. John Michel, who's sadly no longer with us, who was for many years the editor of what was the Seriologist. And a cracking good editor, I have to say. I went to a friend's house in West Bradley near, John Martineau's house, where in his downstairs toilet is a wad of seriologists, not for the purposes some of you may be thinking of, but they are actually, you realize the quality of production and journalism in those early ones are really good. And so, seemingly mysterious number, this is me, not John Michel at the top, seemingly mysterious number patterns also appear throughout current metrological unit systems. And these are of prehistoric origin. Those who study these patterns are currently referred to by academics as the lunatic fringe. Now, John Michel was the pioneer who basically reconnected us to ancient metrology. With him and his friend John Neal, between them, defined a workable system. And it's this book that really did first crack it, which is John's book, but John Neal's hand is in this book, 1981, and from which I took the cover slide. It's no longer in print. Terrible. In the future, this is a book to get if you can find one. This is a book that will fetch a lot of money in Sotheby's one day, because once you've cracked ancient metrology, and when I say cracked it, I mean you've got the system that you can apply when you find ancient monuments. You discover what type of units they were using. It helps you to date a monument, it places it culturally, and it increases your consciousness of the past. And that's the first fruit of it. There's a later book, which is, I'll show you now, which is Dimensions of Paradise. It was written earlier, but it's been revised by John shortly before he died. And that's packed with useful stuff too. That's Inner Traditions in America. Could he find a publisher in Britain for that? Why not? Aren't we the land of innovation? Aren't we trying to encourage new ideas? Wasn't this what Britain was about? But John showed me some of the letters he'd had. Too old, one of them. So let's have a... John wrote this. I think this is the cue for the next part. A tradition which has been credited by many learned men over the centuries is that the ancients encoded their knowledge of the world in the dimensions of their sacred monuments. If that is so, any attempt to elicit that knowledge must be preceded by study of ancient metrology. For to interpret any set of dimensions, it is of course necessary to establish the lengths of units of measure in which they were originally framed. Now, I'm sure none of you are going to disagree with that. The logic of that is impeccable. And therefore, my first call, the title of my lecture, which you've got as very little knowledge, it's a reflection on me, really. It's nothing to do with the subject. And I've changed to a little knowledge. The first conclusion I want to draw today is that actually this is something worth studying, and the crop circle phenomenon is not measured accurately enough at the moment to enable us to understand that wherever these circles are coming from, we need to look at whether, and you'll see later, I can answer this, but you need to ask yourself whether this responds to the ancient canon of metrology or whether it does not. And nobody has satisfactorily answered that, I don't think, yet, although I think it has been answered. But I think it is not promoted enough. We need to have the number of crop circles where the best you'll get for the diameter is about 250 feet. It's not enough. We need to have it to within a few inches, and it's possible to do that, either through aerial photography. I know it costs a lot of money, but if you've got a plane up there, it doesn't cost a lot to have an optical system that records through degrees, and the height of the aircraft gives you the exact diameter. It's how aircraft land these days, with instrument landing. They record the height and they record the angle of the object on the ground. A bit like the dam busters with the two searchlights on the plane that allowed it, when they came together, you had the height above the water. You've all seen that film, haven't you? Yeah. Richard Todd, isn't it? Richard Todd and a whole load of Merlin engines. Just the thing for a wet Sunday. Right, look at this then. If you've not met this before, this will elicit laughter, so wait your cue. The equatorial circumference of the world was defined by the Chinese as 360,000 by 365,000.24. And John Michel was quick to establish that that's in English feet. So something bizarre, we did actually export something to China once. But of course, But the English foot isn't the English foot at all. We call it that because it's found most commonly here. Now, for that to be the case, for the Earth's equatorial circumference to be that, and for that to be almost prehistoric, we have to ask the question, well, obviously, did somebody know the size of the Earth? And then we look at the other circumference, which is the one from the poles round, and we find that's 24,883.2 miles, and it's the Greek foot, and it's 360,000 times 360 geographic or Greek feet. And before you say, well, this guy's just using whatever unit he can find, the truth is we still navigate, all our navigational systems at sea still use the nautical mile, which is based on the geographic or Greek foot, a unit of length that was being used by around Plato's time, at least, and possibly thousands of years easily before that. And so that's the figure we still have for navigation. And I have in the room John Blake, who will confirm that.
That is correct.
Thank you. I'll give you your £5 later. So, how many people have never seen that before? Do you think it might have been important to be taught that in your history class? It might have established something about the history of units of length for a start. I know that might be a dry subject, but the cultural implications of this are enormous. Now, you can change from polar to equatorial by making pi artificially a little bit higher than it is, and all these are constants that can be applied to do it, and there is evidence that all of these were being applied. But historic metrology, that's the sort that needs to be measured in crop circles. Forgive me for stepping back and not facing you, but fractional whole number ratios connected to a defined root foot measure. They're demonstrably related to the size of the Earth, including the polar radius. And we have to ask, well, how the heck did anyone measure the polar radius? Unless there were Jules Verne with a very, very high melting point tape measure. And interconnections be found between seemingly unrelated unit systems from diverse cultural origins are found throughout the globe. And finally, the English foot was often the root foot, and 1 mile is 5,280 English feet, and 1 foot is 12 inches. I've put that in because we have people from Europe who have had the meter since Napoleon decided to have it, and well, it's done them. The root foot can form. You can start with the English foot, and if you move that by 6/5, which is these fractions, you get the remen, which the Egyptians were very fond of, which is 1.2 feet. Times 7/6, we get the Russian foot, or the Northern European foot, which is very, very common in Britain at sites, and that's 1.16666666. The root foot times 8/7 gives you the royal foot. Anything a seventh over the unit is royal. If you look at pictures of kings and queens and on Egyptian bas-reliefs, they're always a seventh higher than the ordinary plebs. The root foot time, then you've got these different feet. There are lots of them. And I'm afraid metrology is a hard slog until you realize it is actually quite a simple system. If you multiply whatever root foot you've chosen by 3/2, you get the cubit of it. So you imagine if you took the English foot, multiplied by 8/7, to get the royal foot, then by 3/2, you'd have the royal cubit, which is there. But basic cubit is always 1.5 times the foot. You didn't know any of this, did you? No. And then cubit times 6/5, sacred cubit, which is the one that, these are the pyramid ones. These are the ones they made the pyramid out of. So the meridian circumference, all these units of length I've talked about, they're all commensurate. In other words, when you do it on a calculator, you get a satisfying huge number of noughts and usually a canonical number divisible by 2, 3, and 5 coming out of the formula. So their intended dimensions were quite clearly part of a system. Now, you and we got a £5 calculator and we can go, but these people, in order to do their calculations, had to do what you'll find in markets, and I have been to China, and I have been to Taiwan and seen people doing this system on abacuses, because the plural of abacus, I believe, is abacuses, as the plural of platypus is platypuses. Platopus. if you use the factors of a number, what you end up on any fractional system is you end up with a load of factors of 2s, 3s, 5s, 7s, and all of that on the top and bottom line, and you can cancel them all out, so they just become dead, and you're left with a final fraction. And if you're a good mathematician, good at arithmetic, you can know this. You can learn it, and of course in China they do, or they did. And then there's this, I don't want to waste your time, because you might not want to invest in this, but let me tell you that there are, to get from the root to the geographic, you have to multiply by that fraction there, and these are all canonical numbers, and very, very simply break down to be multiplied. There's reasons why these numbers are needed. That 441 over 440 was discovered by Flinders Petrie in the Victorian era. It changes the polar radius to the mean radius of the Earth. So it's a conversion to get the thing from the polar units to the geographic, that's on the surface of the Earth. Now, I really think, I apologize for this, but we've only got an hour, so. There's the Earth and the Moon. That's the Moon, hiding away there. There's the Earth. You might have seen Bert's identical picture. He stole it from Wikipedia, just like I did, I think. Is Bert here? No. Okay. 7920 miles is the diameter of the Earth, and 2160 miles is the diameter of the Moon. And therefore, the radius of the Moon is 1080 miles, and the number of the Moon in all ancient traditions is 108. Many of you will know that. The Earth's radius is 3960, and you won't know that, I guess. If you put these together and you put the Moon, you've seen this diagram before, but not with the units on, you end up with what I've just said. And why would you do that? Because astronomically that's crazy. But you find out that 7/19 times this version of pi gives us the meridian circumference, 24,883.2 miles. The meridian circumference we still use by navigational systems. So we've got some sort of, that's a pi that's accurate to a very high level. We can now look at what happens if we connect a circle round to the middle of the Moon, the midpoint of the Moon's disk. And then we get 7920 plus 2160, because there's 2 2160s each side. That's 10080 miles, multiplied by 22 over 7, which is what happens in the ancient system. And you end up with this perimeter being 31,680 miles. This is Plato's sublunary world, which is what happens down on Earth. This is the world. It's one version of the world. The other version is just our planet. Now, we've seen this slide this weekend several times, but the pyramid angle is determined to high accuracy by this thing. John Michel told me once over a glass of nice malt whiskey that, in fact, this originally was written on the back of an Evening Standard on a tube train. It suddenly came to him, and I think he is the originator of it as a result. That is the Great Pyramid, and these of course, are not the dimensions of the Great Pyramid, but it's the same formula. It's 7 by 11, and the Moon is 3, in the ratio is 3 to 11 for the Earth. And that's the respective sides. And John also discovered the 3-4-5 triangle, two of them acting as bookends to support the Moon, to stop it rolling off the top there. Crazy though it is, it appears like this system was part of the definition of the size of the Earth and navigational systems. So I want to now look at another common geometric shape that has a lot... No, I didn't, and I have got it written down here. Thank you, Michael. Excuse me. Slap. Thank you. But as you know, when you're talking to a group of people, it's often easy to forget things.
But it is, in many ways, the most...
That square is the same area, same perimeter as that circle. You saw that. It was Bert actually had it on his earlier, so he did say it. So I'm a bit redeemed, maybe. Half forgiven. I want to look at another shape that we see all through the crop circle phenomenon. It's the generatrix or creative, the feminine principle. It's the symbol of Glastonbury. And what I find really good is to put the earth in the middle there. It's our creation temple. And so it's good to put the earth in there because you can then start to do some interesting things. If you know the distance from there to there, and we just did it, 7, 9, 20 miles, then we might find that we would find some sort of correlation between other temples that represent the earth, such as the pyramid and Stonehenge. And so it turns out that we do. The lintel circle diameter is 100.8 feet. That's through the middle of the flat, completely, perfectly level lintels. And the bluestone circle diameter in the middle is 79.2, which is 100th of what we're looking for. And that is exactly, if we take that as being the diameter of the earth, that is this circle here that we're actually getting now, which is 10,080 feet round. So Stonehenge and the earth are almost copying the dimension I've just given you. This is one of the oldest buildings you're going to find ever, and it's following precisely. These are not John Michel's measurements, they're the measurements of archaeology, and they are fairly accurate. I mean, there's some doubt as to quite how accurate that bluestone circle one is, but that's right on. And the centre of Stonehenge, we can see all that drawn out, that in fact we've got even the horseshoe in the middle allows you to draw a hexagon in, from which there's a neat squaring of the circle shown from here to here, from the bluestone circle, and it comes out over the other one, and that's quite cool. And John Michel, I think, is responsible for that. Here's another vesica at Glastonbury Abbey. Many of you may not have seen this. It was in the first edition of The View Over Atlantis, John's book that was a bestseller. But it takes more or less the Arthur burial place at one side, the Catholic church on the other, the almonry in the middle, and then the market cross here, and the fish pond there. Have you all been in the Abbey grounds? Yeah, if you haven't, you should do that when you go to Glastonbury next time. You can expect all this lot. The market cross is where all the cider drinkers hang out. The Roman Catholic Church has been closed now, but I believe you can get into the Magdalene bit. The angelic bit is still available. The almonry doesn't exist anymore, but it was well known. Now that's interesting because there's a little bit of play on words. Almonry, this shape, the vesica, is the almond. Okay? And I rather like this slide because it's all monde in French. It's all the world. As a true creation, the almond. That's a play on words which you don't have to take any notice of. So we've got this, John Michel had this scheme, and if you follow the hexagons round and don't go through the middle, you actually travel exactly a mile walking round. 1 English mile, right round. So I thought, well, John missed this, but I think in honour of John, I would like to look at the dimensions of this. It's 660 feet across. Now, John had a bit of a problem with other than using feet. I know why, because his system said feet, but I've been finding inches for years, and I've sat rowing with John in a pleasant manner for many years about this. But he never knew about this one. But if you take that 660 feet, 660 feet is 7,920 inches. John didn't pick that one up. So in other words, that distance across from there to there is the traditional diameter of the earth. You can go and measure it. And of course we've got the almonry in the middle. So that's the workhouse. It's where the charity happens. Nice little play on words. And there's St. Mary's Chapel within the vesica. So this is actually a representation of the model of the earth, as all good temples should be. Now here's a similar vesica I discovered in Wales. Many of you will know that the biggest, or the most well-known, it's almost the symbol of South Wales, is this burial chamber, Pentree Fan. And the mountain in the background is Carningley, the Mount of Angels, where St. Brinac was ministered to and ministered to angels. If you look at the site of Nevern Castle and a standing stone, a great big one, 8 foot tall, great big fat one that to the south, Carningley Peak is there, that's this one, and there it is. Pentrevan's there, and Nevern Castle. They're connected by 2 equilateral triangles, equiangled triangles, which means that they're all the same length, these, and they're aligned north-south and east-west, because from this site, Carningley is exactly west. So we've got signs of surveying going on here, but you'd never discover this temple unless you were out there and you actually made this connection. There's some doubt as to how old that site is, but often Bronze Age and sites are later Iron Age and even Norman castles. So I'm not too bothered about that because this Tump is really quite a magical place and has all the energy necessary to satisfy a whole troop of dowsers and pendulum users and meditators. This standing stone stands in a pond, not just a puddle, it stands in a pond. There's fish in it and tadpoles and things. It's only a small pond, but it has pondweed in it. And so we've got an aligned structure, and the question then is, well, what's that dimension across there? And the answer is, if you average all of them, you get 11,760 feet. Now that in itself is an interesting number because it factorizes quite nicely. But it's not the number we're looking for. What we're looking for, if we use Russian feet, which is found in Russia, but all throughout northern England and in Wales you find sites that are based on the Russian feet, which is, if you remember, is 6/7. To get it into Russian feet, which are bigger, you have to multiply by 6 and divide by 7. There's fewer of them. It becomes 10,080 Russian feet, which means the circumference of this circle, the World Temple, is exactly what it should be, 31680 Russian feet. So this is a temple from before from before 3,500 BC, which is the build date of that. And that was built knowing that it was that far from Carningley, and Nevern Castle maybe later, we don't know. But the point is, this looks like a surveyed structure. This is a breakthrough for me, because this joins up the dots on the landscape. And it looks exactly like a surveyor might do it today with isometrics, with same length framework of triangles, triangulation. The fact it's aligned north-south is further confirmation of that. So here we have John Michel's and the ancient system represented in a way that you would only discover it if you had the consciousness to actually be looking, seek and ye shall find sort of thing, and you'd worked out the angles and you need somebody. The only time we've ever discovered that somewhere is a precision site in the Stone Age is by taking a precision instrument to it. Because he ain't got a precision instrument, you ain't going to find the precision. It was only when Tom took a theodolite to Stonehenge that he really started to open up some of the possibilities for it. Same at Avebury. We know how Avebury was, well, we know how the outer circle at Avebury was put together. So we go to part 3 now, where Apollo kisses Ceres. And we start to apply some of this stuff that I've just been talking about. I take it we're all happy with this stuff. Okay, so let's apply it now, not to megalithic sites, let's come forward. I mean, we couldn't have a bigger dichotomy, could we, between a megalithic site that's 5,000 years old, which would be difficult to mow, and a crop circle which might disappear in a few hours. Here's a 13er. We'll look at a couple of crop circles. There's one from about 2002 from Woodborough, just near Alton Barnes. Now, its diameter is said in the book to be about 250 feet. If it's 252 feet, are we allowed to use that? What does about 250 feet mean to you? What's the plus or minus we could have on that? I'm going to suggest 2 feet for this, and then suddenly a lot of things come right. Because if we multiply 252 by 22/7 to get the perimeter, we get 792 feet, right? And 792 is 2 cubed, 3 cubed by 11, and the 308 triangles in it are 4 times 7 times 11. And 792 plus 308, which is the number of triangles in it, makes 1100. So there's a lot of 11s, which I like. I'm up for lots of 11s. And 11s occur in navigational things throughout the area. All the meridian numbers divide by 11. So here's a new factor with this circle, one that wasn't recorded or people didn't look at. And we can also add, you can see here that there are spirals coming out of it, like a fir cone. They're not quite phi spirals, but they form a pattern that you see on sunflower seeds and other Fibonacci-related life forms. And we can do something with that too. There's a secret 7 for a start. That inner circle takes a heptagon, and the inner star arms frame that little circle in the middle, which you see there. Now you can make a circle which follows the first bit of that spiral before it becomes a spiral rather than a circle. And the circle has a diameter of 154 feet. And the circumference of this blue circle is 484 feet. What does that tell you? What is 484 feet? Well, it's 1/5 of 792 feet. So they're related by the phi ratio. So this circle is giving us pi and phi big time. And the geometry of this is very beautiful. So this is a lovely message about we know what we're doing, which we all know they do know what they're doing. Now, there was a book written, which is sadly out of print now, called Crooked Solely, which was shown by Anthony Thorley this morning, just the same. I've not nicked his copy. And this book was written by Alan Brown and John Michel about this unusual formation that formed, they were ready to mow it almost immediately, but it was right at the end of the season in 2002. Now, it's been covered by another speaker, so in some way my work has been made easier, but the point was it represented mitochondrial DNA, which is passed down through the matriarchal line, which makes for some sort of interesting, it's a closed DNA strand, whereas some of the DNA we've seen in crop circles has been opened, and more like the sort of pictogram style of circle. And we can have a look at that. The building of it had to follow this order. There's a lot of geometry here, and I don't want to dwell on it. These same slides were being shown to you this morning. And you end up with that. Now you end up with 504 standing squares, that's the white ones, 792 flattened ones, total 1,296 squared. So we've got 504, which is the radius of the God, it's hard work. Half of the 10,080, and we've got the 792 as the diameter of the Earth there. And we can put this together and draw a diagram where we again get the 660 feet, which was the number of feet in the vesica at Glastonbury. Now, I'm not connecting the two sites together, but it's interesting that there we've got the 1 furlong as a circumference. And if you break free and let the inches take over here, then of course this is 660 feet is 7,920 inches. So we've got the same vibe going on as we had in the other circle from the same year, the pi circle. We've got a circumference representing this measurement. But what's really interesting is that this circle had to be cranked round 72 times to create all those the circles that the DNA follows. Whoops, sorry, my fault. Okay, so we see the circle follows the shape of this band, the snake skin of the DNA, and it goes round and round and round. Now, if you now look at this, we start to see some really interesting things going on. One is that the length of the circumference here is 7,920 feet, but from there round to here, where it cuts, is 5,040. So in fact, that circle is divided by this snakeskin into the two ratios that we've found here and here. So we get another example of this system being applied in a crop circle. Very few people, I think, have read this book. And it's out of print now, and I've been meaning to contact Alan Brown. I can sadly no longer contact John, well, I think he contacts me from time to time, and get some sort of picture of whether this would be worth incorporating in another publication or publishing again. The diameter of this circle is 360 feet. Circumference of that little circle is 2/7 of 7,920. The next circle has a circumference of 5/7 of 7,920. The outer circumference of the snakeskin has a circumference of 10/7 of 7,920. And the final one has a circumference 1,131 and 4/7 feet, which happens to be exactly 12/7 of 7,920, or 990 royal feet. So in fact, the perimeters of these two big circles, that one and that one, are in the ratio of the royal foot to the royal cubit, foot to the royal cubit. That should be stunningly interesting to any of you, because whoever put this together, or whatever put this together, seems fully familiar with the system of metrology, which goes back to prehistoric times, as I've shown. So the conclusions we've got are these. We need to measure crop circles a bit more accurately than we do. We need to, and it's no criticism of researchers, because it's very difficult in a field of standing crop to be putting tape measures across, and all sorts of problems happen. It's hard enough on flat ground when there's no wind, but put that in standing crop, it's very difficult. I think it really needs to be done from the air, by monitoring the height accurately and by having this, basically a theodolite with a 20 minutes of a degree markers on. Then you can do it through stereometry. But I think that's one of the first things I would say. The second thing is that studying crop circles, I realise, is very little different than analysing stone circles. Now, I've got 25 years under my belt of doing stone circles, and I haven't found it difficult to adapt. What is difficult for me is the geometric complexity of crop circles, which of course it far exceeds anything that the megalithic people have left as a record of stone. The second thing I'd like to say, and it's controversial, but I'm not averse to that, is that I have watched in my lifetime 3 times the Lay Hunter Society of Britain pull itself to bits through internal friction because people don't get on. Now I'm getting on a bit, they don't get on, but I am getting on. And I would like to say that I think there have been factions in the crop circle movement in the past. The archaeologists are all at each other's throat at the moment. There's the time team lot, and then there's meet the ancestors lot, and they don't talk. And even in cosmology, everyone's at odds with each other. It seems to me like we want to divide this seamless raiment, this garment, this wonderful system, which is our historical past I'm referring to, and we don't want to share it with other people. And yet it's not really ours. We're not doing any of this for personal glory, are we? We're doing it because we want to share a story which we would like to put out to a wider number of people. I'm sure anyone who organises a conference would like that to happen. Now, it's only going to happen if we're better informed and we're getting on. And to do that, we actually need to record and keep a system of records together that are a common source of information for people. Like the history of crop circles have been well photographed by a number of people, Lucy Pringle, Steve Alexander, other people, and there are quite a few microlight photographers who are doing excellent work. But until we have a closer estimate of the size, we can't look at what I've been looking at, other than at the odd one where we do have some more information. I would love to see a central recording system set up. I would love to see a lot of the injuries that have been inflicted on the movement by various people who've misunderstood each other. I'd like to see that healed. I'm sure there's no one in this room who would disagree with anything I've said. And when we... Right. And when I look in that mirror and I want to shape my environment in the future, I want to see a lot less of this. And so I'm working for a lot less of it. And I'd like anybody who's listening to think the same way. That we need to actually be, if this is about peace, harmony, love and light, we need to actually manifest that. How can we possibly sell it, what's happening, which is miraculous? This is miraculous. I mean, people have listened. Michael's here in the front row. He slapped me earlier. Not many people would I allow that to happen, but I'm honoured, Michael. Thank you. I'm honoured that you slapped me. Michael has been doing this for a long, long time. He has been an analyzer par excellence and diligent, such that his home is covered with the most brilliant artworks in various colours and charts of various crop circles. I know John Martineau used to be very active in crop circles. John Michel was brilliant at painting them. He had a whole exhibition in London of crop circle designs that he'd watercoloured. And so there's an art product. I've got a lovely bowl at home with the Dancing Morris Men one that was at Stonehenge with by the barrow there. Remember that one? Yeah, you do, don't you? Some of you do. And I've got a tapestry done by a lovely old lady at Avebury of a Vesica piscis and a pentagram star. And it was at the end of her sale and no one had bought anything and it was shockingly expensive, but it's got gold thread in it and stuff. And I bought that and I've never regretted it. So there's an art form spin-off from this stuff. But you know, one page in the Daily Mail, come on. This is the most amazing landscape art that anybody has ever seen. And it's coming from an unknown source because nobody's coming forward and owning it. And we might discuss for hours. In fact, we might meaninglessly discuss for hours who's making them. But you've only got to spend time with them. And this is my third point on that, which is it's no use sitting at home with these things. It's much, much better to connect in the environment, in the landscape. Now, that's true of stone circles. It's only because I've spent so many hours, Trish and I have spent so many hours sitting with a monument, various times of day, various seasons, sometimes freezing cold and soaking wet, sometimes absolutely beautifully blessed by the weather and skylarks and one of those perfect days, not this summer. And you need to be in the environment. You need to walk to see these sites. So this conference is really the academic wing of what should be a personal quest, a pilgrimage. Because what those pictures I showed you are the definition of how the ancients defined the world as a created temple. And therefore there's a metaphysical component about all of that and those numbers. And I can't tell you how exciting it has been for me personally to make the journey to understand that lot. I would love to be able to offer it in a simpler format to you than I have today. But it's not actually that difficult. It isn't that difficult. Maybe this winter, when the weather gets bad, you could just spend a couple of hours occasionally just looking at this beautiful, sublime, ancient system of how temples were laid out and the measurements of them. Because it seems that there's an enormous commonality. that was one of these points. And so the discovery of astronomical geometry and meteorological geometry and a geometrical framework coming from the cosmos, we can imagine must have appeared wonderful. It must have appeared like there was some mystical or numinous force, called God in my language, we don't need to give it another name really, that was responsible for order in the cosmos rather than the chaos that everybody is so scared about. Even today, we don't like chaos, do we? Anarchy, chaos, we don't do it. It only lasts, it brings change, but it's basically a very uncomfortable thing. We like security, we like to see these patterns. They tell us that things are going to continue. And there's another one from Babylon. This is a really cool bit of stuff that survived all those years and is in our culture today. There's the moon there. It's the fastest moving object in the sky. From night to night it moves. I keep saying guess what like Burton, I must stop doing that. Guess what? It moves 13 degrees, as you might expect the lady to move. And therefore it's a very fast moving. Mercury can make up to 2.5 degrees in a day, but it follows the sun. It's always near the sun. So its average is at 1, but when it's really going for it, Mercury, it fair shifts per night for night against the stars. Venus is a bit slower, but that's our third fastest. The sun moves 1 degree a day, which is where the word degree comes from. Mars is quite slow. It takes 4 days to move a degree. Our first slide is really to look at circles and the fact that they're found in nature, from the simple raindrop falling on the river or the pond or the puddle, to there's plenty of that around at the moment, to spectacular sites like a double rainbow at one of my favourite sites in the Pembrokeshire National Park, Lecca Dribeth, big slab on a tripod in Welsh, very colourful language, and there's the double rainbow, and that's an arc of a circle. There are built circles, of course, in our environment, and there are sky circles and living circles. We see the disk of the sun and the moon, and we see the sunflower, which obviously is part of that. We saw the picture of Mary surrounded by that in Bert's talk, and there's the transit of Venus just happening there across the surface of the sun, because I still do that sort of mad thing. It's only once in my lifetime, twice in my lifetime, that I'm ever going to see that. And I got the first one in 2004. There's the disk of the sun, and there's the planet Venus. You see how small it is, and how small we must be, how little we are in the immensity of space. And there's a nice built circle, or an arc of a circle. There we are. And there's some lovely circles there, about which there's been a lot of controversy. That's sort of the power point of London, isn't it? Battersea Power Station. And then we've got prehistoric built circles with savages. And there they all are. And mysteriously, these stones have materialized overnight. And Busty Taylor's on an eagle overhead. And they're trying to think that they couldn't do it. So it's impossible, but there's a nice henge with a double ditch and so on. So it all leads us to the fact that human cognizance of the relationship between the perimeter or circumference of a circle and its radius or diameter. And whether you use the modern way of using the diameter as the constant or pi, the traditional one, it's really not that big a deal because you can do either. And I can be flexible enough. So, but the two formula that we learn at school are 2 times pi times the radius gives us the circumference, or twice the diameter times pi is the circumference, and pi times the radius squared equals the area. Now, there are several constants found throughout history used to simulate convenient values of pi are 22/7, which you used at school. In the days before electronic calculators, these were very important for, should we say, less than 100% precise. They're not bad. You can't do many things in life to 99.96%. I certainly can't even get Rice Krispies into my mouth with that precision. And the most accurate, I don't know, I don't eat Rice Krispies. I don't know why I said that. It's absolutely awful food, but it is awful. It is difficult to get in your mouth. All right, that's why I said it. It's not like our local whole food muesli, which is difficult to get out of the packet. The most accurate one we know is this one, 355 divided by 113, and that's almost spot on. I mean, there are so many noughts there as to make it indistinguishable in any practical engineering project, I would have thought. And the historically used value is this lovely 864 over 275, which is the one that you find in the Egyptian monuments again, and quite a few times there's a rough approximation there. So there's pi. I don't want to do this a maths lesson. This is the end of the talk. I can't do Bert, but you're not following me fast enough. You manage with Bert, you can do it for me. You were asleep. You want to see a crop circle being laid? Right. Guess what? It's Bert. So, and it was a great lecture. I'm not mocking. That was a fantastic choreography. So, sooner or later, people appear to have got the message that there was this relationship, and the sky was also informing people of geometry, whether they liked it or not. As soon as they started monitoring where Venus stopped in the sky, which it does every 1.6 years, they would notice an 8-year sequence and 5 stops. And there it is from the year 1990 to 1990 something or other, 98. And it stops at these 4 points, and each time you can draw the pentagon, the little arrows there show where it stops the next time. So it actually can be drawn in one single stroke of the pen. So there's the Earth. We've drawn it in the middle because it appears like the Earth's in the middle. I don't have a problem with that either, but modern astronomers really do have a problem with putting the Earth at the middle, because they think naively that we don't realize where the Earth is. But, you know, if you're on a railway train measuring the velocity of another vehicle next to you, you don't pretend the railway train's not in the middle of things. It's where you take your measurement from. You'd get very badly injured if you did. So there's the Venus pentagon, and it's, of course, loaded with other constants like phi, which we don't need to cover. But what I want to say to you, first of all, a central theme of this lecture is that time and space are involved in this process. It's no longer about just space. You have to wait the 8 years, and you have to remember which star Venus stopped next to in order to record over 8 years. It requires a certain level of consciousness and measurement and observational accuracy in order to define this. It is a pretty accurate pentagram. It only moves 2 degrees at the end of the cycle, so it takes sort of 1,000 years to rotate slowly around the sky. But there it is, the Venus pentagram. Those of you who were up during the fine weather in the spring, when the weather was looking like it was going to be nice in the summer, will remember that Venus, for night after night after night, was gradually slowing down in March and April, a wonderful spectacle. Every month the moon was going past it, and you were getting a free Muslim flag in the sky and things like that. It was a very good time.